In this video, I want to talk a little bit about Exosides Quad Remesher, which I think is pretty awesome and great tool for modeling. So first of all, you can see, for it to see what kind of remeshing it can do, what they have is test geometry. Then I voxelized it. You can see now it's the complete mess. But what I did with Quad Remesher, you can see we are getting very nice quad topology. Basically the same primitives. So we have 10,000 here, and the original was 12,000, but of course it's very different. So since I voxelized it, it's now one shape. So it's basically the same amount of. So these are meshed together when I voxelize it, but it's basically the same quad density and getting very nice quad remesher. So this is a very powerful node for our geometry modeling. Now let's take a look at a couple of examples. So first of all, I have boolean, which is basically the same setup for both of them, two identical booleans. But I have in here boolean. Both of these booleans are reverse faces. So reversed output primary group is just the faces that are created when we boolean out something. So you see that in blast, if I delete the reverse faces that I just checked in a boolean, you can see it's basically the faces that are created. So I'm going to disable it. And now in Exosides Quad Remesher, in side you can see you can reference this use primitive group boundary. So now it knows basically this is a group boundary that we should, and it's going to kind of create the topology around this boundary for our groups like that. So you see this is the results that we are getting, which is pretty good. It's pretty light weight, 247. So, and this is the example where I do not use the primitive group boundaries. So you can see it's not even, it is still created a group, but we are not referencing it as a boundary. So for this you can see it is now almost 500. So basically twice as much topology. And it does look nice, and it's really good for subdividing. But if you want to do some more modeling, it's probably not the best idea to get already this. It's kind of starting to get little too many polygons inside in here. So this is definitely one way we could do to get a perfect kind of a cutout for this circle. But what I would actually do is go back to the exercise with primitive group boundaries. I would basically just go to the normal selection and delete these. And then I would just go select this edge and put down a circle from the edge, like that. Now I have a perfect cutout for our tube, for our sphere. So, but for us to clean up this process, what you can do is actually let's delete these. Let's just go to the boolean. Let's just blast our reverse faces, and now we remeshed it. And you can see, and we can actually disable this use primary group because we do not have any groups anymore. So you can see, you're now getting pretty good circle. Then just select it, circle from edge. It's like this. Now we can just poly extrude it. Let's extrude it inwards, like that. Let's bevel it, like that. And now let's subdivide it. You see, you're now getting basically perfect result. And for the most part, it's basically just because of our quad remesher did all the job for us to get this shape. Now let's take a look at another method we can do. So first of all, I have this basic setup again, but this time we have for our boolean, we are at one boolean merging two together and boolean about like that. You can see, and now we're remeshing it. So target, I upped it up a bit, 500, and still use primary groups. So in the back we're getting pretty good results. In the front, you can see not all of these are quads, so might be time for us to play around with quad count. So if you do all the operations at once, you might get these kind of results, and it's still very usable topology, but still. Alternate method, what you can do is actually go to the boolean and do each operation once. So what we have is we're booleaning out this, and then we are remeshing it with use primary group boundaries, and then we are booleaning out the back of it again, and then we are remeshing it. You can see we are now getting the same object, but the result is quite a bit different. So this is our boolean all at the same time, and this is our boolean one at a time. You can see we're getting a lot nicer topology around these areas. The back of it is pretty much the same, but still it is a little bit nicer when we do separately each one of these. So This really depending on what you're looking for. And now what you can do is even bevel it out. So for this topology, what you can do is actually put down the bevel, go to the exclusion, ignore. So first of all, let's delete the group. So now let's start excluding. You can see now we're selecting this. Subdivide, you can see now we're getting very nice result on the back also. So for this, obviously, once we have remeshed it, if you want the perfect circle, we could just select it and create a circle from the edge, like that. Now we're getting a perfect circle, like that. Another reason I like this topology tool is because it does do very well with the hard edges. So what I wanted to do is create this kind of a dome, but of course you can see there's lots of hard edges on it. But so I thought before this quad remesher, I send it to ZBrush. So in ZBrush, I imported it and I just used the remesher. So in remesher, so I put in the same amount of polygons and detect edges and Z remesh. You see it does pretty good job, but some of these edges you can see, these very hard edges, you can see that these are not exactly perfect. So it does a good job, but not perfect job with the hard edges for the remesher. So you would probably have to like play around with these. And if you deselect these detect edges and Z remesh, it does a very bad job with this one. So, but with this node, it actually does a very nice job with the hard edges. You can see, put down basically the same options. Target 500. You can see these are very nicely polygons, very nice quads with all of the edges. And put down normal, harden up. You can see it does basically a perfect job with remeshing, even with these edges that in other remesher it is kind of quite a challenge for them to remesh it. And you can also symmetrize it since we have all of the same basically on all x and z axis. We can x and z symmetrize. You can see that basically we are now cutting up it perfectly at the global reference grid. Another important option inside Quad Remesher is to detect hard edges by angle and use normal splitting. So first of all, it's not really recommended to use them both at the same time. So first of all, what we have in here before we quad remesh, we have this geometry, but you can see if we middle click on this node, we do not have a normal. Even though these edges do look like split, actually we do not have a normal attribute, and it's really Exosides Quad Remesher won't actually recognize these split edges right now because they're not actually just for the viewport. So if you go to the exercise and use and press on use normal splitting, you can see nothing is going to change. It's basically the same thing. So let's just put down normal node before the exercise, and let's just leave it at just exactly how we have before the normal, like that. But now we have our vertex attribute, and you see with the normal splitting with the same options, you can see we are now hardening up all of these edges that we have hardened up inside before the exercise remesher. But you can see there are a couple of places where it's not ideally subdivided. So what I like to do is for something like this, actually let's put on symmetry. So we have to worry about only the one side. Then you can start just playing around with these quad remeshing out. So you can see now we have pretty dense geometry, but it did quad remesh. And let's just do the same thing, only with the detect hard edges by angle. So let's deselect it and use detect hard edges. Let's put it back to maybe 500. You can see without normal, you can see we can also disable this normal. And with detect hard edges, it tries to basically detect hard edges, and without even normal attribute, it's going to detect them. And you can see we are even getting a better result than with the our hardened up edges. So it really depends on the options you want to use. It's always good to use the adaptive size if you want more geometry on the parts where there's maybe tighter turns in geometry. So that's going to coming up next. Now let's talk a little bit about how can we color in the density for our mesh. So what I have in here is my previous video, the gun grip. So first of all, let's put down a remesher. So for me, it's basically the already subdivided mesh. Let's point it in here. So first of all, you can see it's lost all of his detail, but first of all, let's take a look how many primitives we have in here. So in here we have basically 12,000. Let's put it also 12,000 inside here. So now let's take a look at the result. So it's pretty good. So before since we have subdivided, let's deselect the hard edges so we can clean up this part. That's a little bit better. So let's disable use primitive groups, and also let's put adaptive size to 100 because we do want more geometry in these creases. So you can see it did very nice job with remeshing, but it's still not as, see, it's a little bit tighter in here. So what we can actually, but overall I think it's did very nice job with remeshing it. Let's take a look how many primitives you can see, but also we can see that it's basically 23,000, basically a lot more, almost twice as much. But if we want to just make a low poly from reduction, it's actually fine. And if we want to create some holes in it or modify it with booleans, we still want our usable mesh. So this is not too bad with twice as much geometry, but we can still edit it. So first of all, I want to talk a little bit about painting in the density. So now let's talk about how can we deal and modify our geometry that's with high subdivision amount. So what I have is my gun grip. So first of all, let's start with let's put down the remesher and let's remesh it with the same amount of polygons. So you can see now we have remeshed with the 1500. You can see it still did pretty good job. But let's say we want the around, let's put down exactly the same amount of primitives. So 11,000, so basically 12,000 polygons. Like that, let's remesh it. So let's turn off hard edge detection. Like that. So we have nicer here results. And let's also put down adaptive quads to 100 because we have parts where there's a lot of geometry, like in here, very tight geometry. You can see at our mesh, it's did pretty good job. Maybe some of these creases, there's where there are more polygons, it's not as visible, but now it still remains all of the details. And let's take a look at our geometry amount. So we have 23,000, so basically twice as much polygons, but it's still not too bad. If you want to, let's say, if you want to, let's say, make a hole in here, it's still pretty good because we can always remesh it. So, but before we do that, what I want to do is actually do one trick is, if you know that you want to remesh it, basically with the same quad amount, and take a look at the results, you can actually create a, you can basically create a preset. So what I want to do is, instead of writing it by myself every time how many polygons I want, I'm basically going to write and prim, and then in brackets 0. This expression and prim is going to basically say, give me the same number that we have connected to geometry. So you can see 11,000, and if you take a look at this and prim, it basically got fetched the number of primitives we have in this geometry and put down as a target quad count. So that's one way we can easily automate and create a preset. So let's say I want this preset to be as one I'm going to use often. So make sure you have adaptive size, this turn off, you can even turn off this one. Let's say let's allow the symmetry, and then just go here and then say preset. You see I have this high remesh, same source preset, the same one. It's gonna remesh it. It's gonna look like this. So this is very useful. But for now, let's start with the how we can we paint in our density and maybe get less primitive. So first of all, we have to do is put in attribute paint. Stop before the actual quad remesher. So in attribute stop. So one thing to note that you can see that you can press on use vertex color, just press on it. It's gonna remesh it. It's gonna take maybe 2 seconds. You can see that it says set up attribute paint stop. Press on it. So for me I'm not really sure, but it didn't really usually do anything. So what I do is basically set it up myself. So what I have is my setup, remesher colors. So for the remesher, basically all I have to do is color in the red, so it's actually going to so I don't know, sometimes it works, this setup button works, but for me it doesn't really work, so I just created the basically the same attribute paint, and I just create a preset that is my remesher colors. So even when you go to the remesher, you can actually hover over the paint quad density. It basically says that big quads is going to be cyan color if you want to less topology there, or if you want smaller quads, it's going to be red color. So in attribute paint, all we have to do is make sure that it's at CD attribute that we are painting in, and for the foreground color, put in the red one, basically 1 0 0, and for less it's 0 1 1. So and then just start painting in the parts where you want more geometry. So let's say I want more geometry in here. I'm just going to start painting it. Obviously we could also symmetrize our paint, but since we are actually symmetrizing our geometry that we remesh, you don't really have to worry about it. So just paint it like that, and then go back to Exoside. You can see it's very obvious we have created a lot more geometry around our grip. For demonstration purposes, what I did in attribute paint, I painted with 0.1 color and with the full color 1. So also for symmetry, you can go to the symmetry under it and enable symmetry. Basically going to paint in x-axis if you have 1 in x, so like that. So you can see I have painted with 1 for this, and you can see the result. It's a very dense geometry in here, and even in here they start to kind of break up everything. So maybe I could paint a little bit more, and with this I paint with 0.1, so with the very light, very dark color. But you can see we are getting a lot less geometry, a lot dense. So you can see you can you can basically compare, so 0.1 and 1. You can see how can we control the density that we paint in. You can see that even the lighter one is actually getting a lot nicer results. Like in here, in a dense one, you can see it start to lose up some of these patterns that we are creating. And for the opposite, where we want less dense geometry, we have to use the background color. For by default is basically a middle pause button. We paint in a cyan color. So let's take a look. Let's say I want less geometry in here. Let's unfreeze it. Let's take a look. You can see it's very obvious that right here we have a lot less geometry. So you can see it still looks actually pretty nice. Now to round up my Exosides Quad Remesher overview, what I'm going to do is actually let's boolean out a hole inside here, and let's take a look at how it's gonna take care of it. So you can see we are remeshing pretty nicely. So before we remesh, let's put down a boolean. Let's connect it, and let's put down a tube. So first of all, let's make it an x-axis. Let's move it. So probably want to move it. Let's view this. Let's scale. Let's move it in here. Let's uniformly scale it. Maybe somewhere in here. Let's say we want a hole in it. So like that. So this looks nice. What's good about this? Our paint still holds on our original place, so we won't have to worry about if we want to paint in our density. We basically do it before we boolean, and it still works. Or we could also paint it after the boolean. It doesn't really matter. So now we have this. Let's say we want to this hole in here. Let's go to Exoside Remesher. So you can see it's right now it's not perfect. First thing I want to do is go to boolean and create the reverse faces boolean. So I want to create these reverse faces. So basically reverse faces are going to be all of the faces that we are going to create when we boolean out this. So basically all the inner faces. So that's a primitive group right now. When you take a look at Exoside, what kind of difference it makes, you can see that it's basically going to create all of this around. A lot nicer topology around the hole that we just cut out. And for us to little bit make it better, to make it more round, you can see it's not very round right now because our tube did not have very much actually topology. So what we could do increase the topology for our tube that we boolean out, then remesh it. You see now we're getting a lot nicer circle, but you can see that not always you're gonna get the perfect quad around it. So let's say I want to make it a little bit higher quality. Let's say I want to bevel it out. You see there's an end cone in here. It's not gonna create this kind of artifacting. So probably the oldest trick that you can do is go to this, select binormal, select all of this inner face and just extrude it. Extrude it inwards a bit like that and then turn it off. Select binormal, then you can just take this and then let's bevel it out. Now we have a perfect quad. It's going to bevel out very nicely around it like that. You see we have now basically remeshed it. All of our detail is still here, remeshed very nicely. I really like this node. I think it's very powerful node for Houdini to have, and I'm gonna use it in my next tutorials definitely. So more modeling tutorials coming up, and hope you enjoyed this comprehensive look at this quad remesher. And also what I want to talk about is a bit that I do have a modeler, direct modeler add-on, so I'm going to use it also. So probably review overview coming up in next week, so stay tuned for that. So that's it for this tutorial. Hope you see you next time and take care. See ya.